Hello, everyone. I'm Fernando Salas, and I'm going to talk to you about Scudo caching. Basically, a little bit of background. Scudo is LLVM's hardened memory allocator. It's split up into primary and secondary allocator, one that deals with much smaller allocations and much larger allocations depending on the configuration that's passed in. Basically, the secondary allocator is a memmap-based allocator, and it uses a cache, which is basically just an array, and a linked list of in-use memory blocks. So basically, I was trying to accomplish optimizing the secondary caching scheme. It's a larger allocator, so it gets called less frequently, and it will return a cache block, or it will have to call mmap to return a new block to the user process. So what was implemented at the time was just a first fit algorithm that returned any available cache block. But that led to a lot of fragmentation, and the first idea was to reduce that using a best fit algorithm. And I did this mostly using ADB to compare results. So basically in this situation, here, the first fit algorithm immediately goes to that 256 kilobyte block, and it leads to a lot of fragmentation. And then I implemented best fit, and that reduced the memory fragmentation significantly, but it also led to slowdown. So here's some of the results I had. So it caused a slowdown. It was still significantly fast, but I figured we could find a better way to sort of have a compromise between these two different options. So basically my compromise was an optimal fit. I did this basically by setting an upper bound limit to the amount of fragmentation we were allowing. So basically it's all localized to one variable inside of Scudo where you can set that amount. I set 10% because that's what achieved the best results for me, where it was still fast, but it reduced fragmentation quite a bit. And here it immediately returns when we get to that 80 kilobyte block. So basically from here, I found that we were able to reduce fragmentation significantly. And from that, we can basically ensure that mmap is being called a lot less because there's a lot less memory waste. So after testing this, I actually realized that each processor device is actually really unique and needs a lot of different sort of memory needs. So by localizing that to one variable, the hope is to eventually have it configurable, as in when we pass in that configuration to the allocators, it would be great if the user was able to identify how much fragmentation they were willing to lose. And yeah, so that's basically the next step. So basically, I use stat stumping to accomplish all of this, and that stat stumping is available to everyone who uses Scudo. And this is a little overview of what it looks like. So in the top right, you can see the fragmented kilobytes, and each of these sort of lines is basically one of the blocks that is in the secondary cache. So you can see its size, start address, end address, and this is just really helpful when sort of trying to see how your process is dealing with the memory in the secondary cache. And yeah, that's basically it.